I'm recording. Hi, Cheyenne. Are you in the same room with everyone else, or are you somewhere else? Okay. So where's the Volkswagen?
Mine.
I saw some people have taken the test, and I was able to go through and I can look at answers if something came out wrong or marked wrong when it should have been marked right. And something like one, there was a comma in the wrong place. It should have been moved out of this fraction, and I was able to give points for that. Another one was a misunderstanding. Someone put a decimal instead of an exact answer, which has like the square root in it. So like if it's square root of 3, that's going to be the exact answer because square root of 3 is irrational. You can never express it as a decimal. So to get it exactly, you can approximate it, but you can't do exactly. So what do we want to talk about today?
All right, so I don't know what it is even called.
Do you have a question?
Yeah, it's a question. It's the find 2a minus 4b type. And we're given like u and b, and for u I got 4, -2, and then for b I got 2, 3.
So it's 2a minus 4b. And so it's vectors. And they give you vector A and vector B.
Yes.
What do you have for vector A?
4, -2.
And for B?
-2, 3.
So like that? Am I representing it correctly?
Yes, it is.
Okay. So when we do a problem like this, it's probably a lot easier than you think. It's going to be 2 times the vector A, which is the 4, -2, minus 4 times the vector B, which is -2, 3. So we'd have 2 times 4 is 8, 2 times -2 is -4, minus 4 times -2 is -8, 4 times 3 is 12. So now we're going to do the operations to bring them into 1. 8 minus the -8, the -4 minus the 12. So 8 minus -8, that's a double negative, so that makes it plus, so it's 16. -4 minus 12, that's a -16. And that should be your answer.
Okay, that makes a lot more sense.
Now, the problems I posted or put in the test, they should have a video in them. If you
Yeah, I did watch the videos for them, and I did have the videos explained it out, but I still ended up getting the wrong answers to them.
hopefully this makes sense if you want to do another attempt, because there are several
Yeah.
attempts allowed.
Oh, I saw how many attempts they were. And then I have my second question is find the projection from B to A.
Let me clear off for that one. I'll make another screen. Find the projection of what onto what?
B to A.
Of E to A.
B as in boy.
Oh, B. Did it write it out like that, or does it say the projection?
And then I got 2 vectors.
Hang on.
Okay.
The way we label this is really, really important. So get the right verbiage down. Normally it's a projection of something onto something. I'm gonna say this is gonna be saying projection onto V. So the A goes there and the B goes here, maybe like that. And this would be U, or in this case, B dot A over the magnitude of A squared times the vector B. So I'm hoping I'm reading this correctly with the terminology they put. So when you say a projection of U onto V, or in our case, B onto A, the B is the vector on here, A is a little subscript, and this would be the format it follows. Nope,
Alright.
nope, hang on, one mistake. That should be an A. There we go. Okay, so what'd you get for, what did they give you for vector B?
So for B, I got -4, 2.
And for A?
A, I got 3, 2.
3, 2. Okay, and this was, they gave you the vectors, or did you have to calculate the vectors?
It just gave me the vectors.
Okay, perfect. So when we look at B dot A, that's our first part. So that's going to be that first component, -4 times the first component of A, which is 3, plus the second component of B, which is 2, times the second component of A, which is 2. That's -12 plus 4, which is going to be -8. So that's our numerator. And then our magnitude of A squared, well, that's going to look at the square root of each component, 3 squared plus 2 squared. And we're going to square that amount. So the squaring undoes the square root. That's going to give us 9 plus 4. 3 squared is 9, 2 squared is 4, 9 plus 4 is 13. So the square root of A squared is 13. So our projection of B onto A is going to be this B dot A, which we found was -8, over that square, the magnitude of A squared is 13, times, that's going to be times now this vector A, which was 3, 2. So that's going to be -8 times 3 is a -24 over the 13, comma, -16 over 13. So -8 times 2 is -16. Do they want an exact answer, a decimal approximation, or what do they want?
That's all that they wanted, I think.
Okay.
All right, those were the only 2 questions that I really had. Thank you.
Hope that helps.
That really does help me out. Thank you so much.
Okay, who's next? Who's in the hot seat next? So we still have at least, I think, half the class needs to take the test. So hopefully everyone gets it done today. And I have to understand, not everyone does it on the first day it becomes open. Some people wait till the last day. So I get that. But give yourself time in case you want to take a second attempt at it.
This is the rest of my day.
Hey, Mr. Downs, could you answer question 41 on section 9.5?
9.5?
Yeah,
We're not going that far.
no, we're not going that far.
Can we just go to 9.3?
I don't know, I'm just trying to give us answers or questions to answer.
Yeah, I mean, it's not an assignment. We stop at 9.3.
What about question 58 on 9.1?
58, 9.1.
Yeah, No worries.
I made the test for chapter 9. It's a shorter test. So, questions are worth more, so good or bad. Okay, so 58, we have 5x squared plus 8y squared equals 40. They want us to find the eccentricity and the lengths of the minor and major axes. Okay, so when we're doing an ellipse, we always want to have this term on the right side be a 1. So we're going to divide everything by 40. So that's going to give us x squared over 8 plus y squared over 5 equals 1. So our a squared is 8, our b squared is 5, and now we got to find c squared. Isn't c squared equal to a squared minus b squared? Yes, no? Yes. So c squared is going to be equal to 8 minus 5, which is 3. So c would be the square root of 3. Now our eccentricity is going to be equal to c over a. So that's going to be the square root of 3 over a is a squared is 8, so a must be the square root of 8 or 2 root 2. So it's square root of 3 over 2 root 2. And if we rationalize that denominator, which I assume they did, I'll look at the answer in a second, that'd be the square root of 6 over 4. So for 58, apparently, oh, wrong one. Yes, that's correct. Now, and good on you, that's an even problem. That's an extra one you're doing. They also then want to find the length of the major axis and length of the minor axis. So length of major axis is going to be 2a. So that's going to be 2 times 2 root 2, which is 4 times the square root of 2. And then our b squared is 5, so b must be square root of 5. The length of the minor axis is 2b, or not 2b, huh? Couldn't help. So that's going to be 2 times the square root of 5, and we'll leave it like that. Okay, does that answer the question?
All right. Hey, what's up? How's it going?
Good, how you doing?
I'm doing all right. So then I was taking the exam a little bit ago, and there's this one question that really confused me.
Okay.
It was the unit something of a vector. I just couldn't get it.
Is it
I think
the
it was unit rate or something.
unit
not-
rate? It's it's 8.5. So I think what we're after is the unit vector in the same direction as the vector you're talking about. So let's go ahead and do another problem like this. Let's say we have the vector A equals 5, 7. I just make something up. So if we want the unit vector in the same direction, what we're after then is we have to find the magnitude of the vector and then divide by that magnitude. So what's the magnitude of A? And that's going to be the square root of 5 squared plus 7 squared, the square root of 25 plus 49, or the square root of is that 74? Yeah, that makes sense. So that's the magnitude of A. So the unit vector is going to be 1 over the square root of 74 times the vector 5, 7. So that's
Right.
going to be 5 over the square root of 74, comma 7 over the square root of 74. And I believe that's how you can leave the answer in the test. Think of what's the exact value, and that'd be the exact value. You can get a decimal approximation, but that's, I believe, what they're after on the test.
So that's it?
I think that's what you're asking.
Yeah, that looks about right.
So this is chapter 8, section 5. And I'm looking at, like, example 4 is one that's like this.
All right, well, that was really my only question.
Okay. Who's next? Are we good?
I think so.
Yeah, we're good. Thank you.
Okay. Thank you. I'll get this recording done and then I'll get these pictures posted. So
By the way,
everyone have a good day. If you have any other questions, you can also post them in the discussion board. Okay, I'm gonna stop the recording.
Where'd you go on your vacation? Oh my God.
Is that a question for me?
yeah,
So well, the one for spring break, where did I go?
Yeah, because I saw you posted a picture of like